Note 6-2. Okay, here we go. First things first. We start off with the parent function for all quadratics. That is y equals x squared. Okay, for those that don't know what that is, that's a U-shaped graph. It goes right to the origin, as most of our parent functions do. Okay, when you graph this bad boy, everything you do today is going to be in your calculator, but I will show you some tricks of the trade along the way. So we hit y equals, clear out whatever garbage the other class had in there. Y equals x squared. Hit graph. Sure enough, I'm going to see a U-shaped graph going right through the origin. But if I wanted to know what that vertex is, because I like to have my vertex and put it right in the middle of my graph, of my table, since it's the middle of my graph, and then I build on it on either side. Each side is symmetrical. Okay, so is that the lowest point or highest point of the graph? That is the lowest. So I go second, trace, and number 3 is minimum. That is the lowest point. Just like when we were doing zeros over there. Okay, you'll also find out today zeros are also called roots. That's another word for it. X-intercepts is the other word. It says left bound. I'm looking for that vertex, so I take my little spider guy and I move it to the left side of it, lock it in, and then I move it to the right side and hit enter and lock that one in. Guess, hit enter and lock it in. Now here's the thing with these older calculators. Okay, with the older calculators, look what it says. E to the negative 6th power. This one says e to 12. With the older ones, if it happens to show up like that on yours, anytime it says e to something when you're doing this, that just means 0. Okay, if it's e to something, that is 0 for these calculators. So 0, 0 would be that vertex. If it said, let's say it said 1.000000005. That's just because these calculators are so old, they don't know how to get it exact. That would be exactly 1. Okay? So if you see a bunch of zeros in a number, it's whatever that number was that was the whole number. Okay? Anytime it says E, that's automatically 0 for these. So we type it right here, right in the middle, 0, 0. Okay, 1 less than that is negative 1. 1 less than that is negative 2. 1 less than that is negative 3. Then we go 1, 2, 3. Whatever I get on one side, it's a mirror image of the other side. So I just go to my table. To get to my table, second graph. I go to negative 3. Negative 3 says 9. Okay, so negative 3 is 9. Negative 2 is 4. Negative 1 is 1. And then it repeats itself. 1, 4, 9. These are 10 by 10 graphs, so 9 is 1 shy of being to the edge. So if I go over negative 3, 1, 2, 3, and up 9, that's 1 shy of the edge, put a point. Negative 2, up 4, 1, 2, 3, 4, put a point. Negative 1, 1, put a point. 0, 0 is my vertex, put a point. And then it just repeats itself on the other side, so you just mirror that. What you just did. You don't even need to count them, just mirror it straight across. Now, with this quadratic, even though that's the only points I did, I ask you guys to go ahead and go past it and throw an arrow on the end so you know it keeps on going forever and ever, amen. Okay, translations. We talked a little bit yesterday about translations and that you do what your opposite of what your folks say in the house and do exactly what your friends say outside the house. That's what this stuff is. This is translations of the parent. So it's taking our parent, doing some things to it to move it around. Okay? Here's the move it around. The house that I keep referring to is any kind of enclosure, whether it be brackets, whether it be absolute value bars, or in this case, parentheses. So inside parentheses is going to determine my horizontal movement, my left and right movement. And it will always be the opposite. So if I had a 3, my folks told me to go 3, that's to the right 3, right? You would actually go to the left 3, a negative 3. Outside, anything added or subtracted to the end is my vertical movement. That's when my friends tell me, hey, let's go up 3 blocks, we go up 3 blocks. Let's go down 3 blocks, we go down 3 blocks. So it's exact. So it's opposite here, exact there. That'll give me my vertex. So using that newfound knowledge, the vertex here, without graphing it, would be what? Opposite of what's in the house. So what's opposite of that? positive 5. And exactly what my friends tell me to do outside would be negative 8. That should be my vertex. We will confirm that with our calculator. Y equals, clear, 2 parentheses, x minus 5 close parentheses squared minus 8. Okay? Alright, once I do that, I hit graph, and sure enough, it looks like it was moved over, positive direction, probably around 5, and down, probably around 8, I don't know, but that's still what, a maximum or minimum, that vertex? It is a minimum, so I go second, trace. Minimum, God bless you, is number 3. Left bound, so I get my little spider guy, and make sure he's on the left of the vertex. I hit enter. Says put him on the right of the vertex. Hit enter. And then it says guess, so I hit enter. And it tells me 5 and negative 8. That 0.000002 is just this calculator not able to go exact. It is exactly 5 and negative 8, which is what we said it was to begin with. So we throw that right in the center since the vertex is the center. We count down from 5. That would be 4 and 3. We count up from 5 is 6 and 7. Go to our table, second graph, and we go to number 3. And 3 is 0. Just reading it out of my table. 4 is negative 6. And then it repeats itself on the other side. Simply plot those over here. Over 3 up 0, put a point. Over 4 down 6. Over 5, that's 1 more over, and down 8, that'd be down 2 more, and then it repeats itself. So then I don't even need to count them, I just draw them because they are a reflection, one side of the other, symmetrical, and goes on forever and ever, amen. Number 3. What do you think the vertex is for number 3 without graphing it?
1 and 5.
Close.
Negative 1.
Forget about him for a minute. It's only
one.
in the house
X.
and outside the house. So inside the house, what do you say, sir?
Negative 5, 0.
It is negative 5, opposite of what's in the house. Nothing is outside the house, so we put 0.
Alright.
Okay, the negative 1 simply does what to a graph? Can't see me. Vampires can't see it in the mirror. Reflection. So it takes that graph, which in our cases have been happy faces, right? It's been parabolas open up, and it's going to take it in, make it open down. Okay? So here we go. Here, we'll put that negative 5, 0 right in the middle here. And let's go ahead and graph that. Y equals, clear, negative 1, parentheses, x plus 5, close them, squared. And now when I hit graph, it should open up down. Sure enough, it does. It did move it over negative 5, 0 for my vertex. Now, would that be a maximum or minimum? That's a maximum because it's the highest point of the graph. Okay, so let's go ahead and find the rest of our points. 1 less than negative 5 is negative 6. 1 less than that's negative 7. 1 more is negative 4. 1 more is negative 3. Okay. All right, we fill them in. Too easy. Second graph. And negative 6 is negative 4. And then negative 1. And then it repeats itself on the other side. So we go over negative 7. That's 3 from the end. Down 4. 1, 2, 3, 4. Put a point. Over negative 6. Down 1. Put a point. Negative 5, 0. And then it repeats itself. And we throw the arrows on the end because it goes on forever and ever. Go ahead and flip it.
The road goes on forever, and that party never ends.
Yeah. Flippity dippity. Alright. Alright, how about this guy? Do you see a house on it? There is no house, so there is no left and right movement. So that means that my x value is 0. What's my y value for my vertex?
3.
3. Beautiful. Put that right in the middle. 0, 3. It's a reflection because it's negative, yes. 1 less than 0 is negative 1, then negative 2. One more would be 1, 2. Okay? We throw it into y equals in our calculator. Negative x squared plus 3. Second graph. Negative 2 is negative 1, Jolie. Negative 1 is 2. And then it repeats itself over here, 2 and negative 1. Go ahead and rough sketch this over here, over negative 2, down 1, over 1, up 2, 0, 3, and then it repeats itself over here. Fill the arrows on it so it knows it goes around, so it knows it goes forever and ever. All right. Next thing is root form. Root form. Roots, again, are also called zeros or x-intercepts. It's the ones that I drew up on the board up there, so it's where it's going to cross the x-axis. Notice how it says in root form, if they're in root form, it's the negative of it, so basically all that's saying is opposite. Opposite of whatever's in here will be where it crosses the x-axis. That'd be my roots. So what's the opposite of that one? Positive 3. How about that one? Negative 1. So it should cross at negative 1 and 1, 2, positive 3. Okay? Vertex, without even graphing it, is the vertex going to be a maximum or minimum? A minimum. How did you know that? It's not a what? What's not out front?
Function.
Not a negative out front. Okay, here we go. So y equals, clear, 2 parentheses, x minus 3, close them, open them, x plus 1, close them, graph it. Sure enough, it's opening up. So that is a minimum. Second, trace. Minimum, which is 3, says left bound, put it to the left of my vertex, hit enter. Put it to the right of my vertex, hit enter. Yes, hit enter. And we know that 0.99999999997 would be what? It'd be 1, okay? 1 and negative 8. So my minimum is 1 and negative 8. Put that right in the middle. 1 less is 0. 1 less is negative 1, 2, and 3. Okay? So if we did it correctly, when I go to my table, those 2 points should pop up. And if I go negative 1, sure enough, it says 0, which is exactly what you already put on your graph. 0 is negative 6, and then it repeats itself, negative 6 and 0, which I've already put on my graph. 2 that I did not graph, 0, negative 6, 1, 2, 3, 4, 5, 6, put a point. And over 1, down 8, put a point. Oh, and I didn't do that one right there, put a point. So it goes like that. Okay? And last, what are my roots? Positive 2 and positive 2. What that means is that's called a double root. That means it just goes down, hits the x-axis, and goes right back up. Obviously, we can't cross 2 twice. It just touches it, goes up. Is this going to open up or open down? Down, because it's a negative out front. Okay, so here we go. Let's do this dance. Here we go. We go clear, negative 1, parentheses, x minus 2, close them, open them, x minus 2 again, close them, graph it. Sure enough, opens it down. My root is at 2. It's touching right here at 2, which means that that also must be my vertex, which is over to 0 if it touched the x-axis. And it's right there at the turning point, then it has to be my vertex. If you didn't know that, you could have did maximum, okay? Second trace maximum, and it would have told you to 0. So I put that right in the middle. 1 less, 1 less, 1 more, and 1 more. Go ahead and go to our table. And at 0, we have -4. At 1, we have -1. Then it repeats itself on the other side. So over 0, down 1, 2, 3, 4, put a point. Over 1, down 1, put a point. Over 2, 0, put a point. And then it repeats itself after that. And then it goes forever and ever. Amen.
It turned off.
And what we did at that point, let me get it back on the screen.
Oh, smile, come on.
What we did at that point was 6-2.
I need a word.
Yep, we did 1, 3, 5, and 6. This concludes notes for 6-2.